Welcome to Inside Physics. In this session, we will see what is a PN junction. So it is used mostly in semiconductor electronics like diodes and transistors. How to form a PN junction? So there are so many ways. The best way is to take a P-type semiconductor material like silicon and you add some pentavalent impurity to that P-type silicon material. So whenever you add some pentavalent material, the impurity to this P-type material, some part of that material will become N-type. That means the pentavalent impurity brings additional electrons, free electrons into that material, and this entire P-type material will become a PN material. That means all the holes which are more in concentration will be left aside to other side, and where we have introduced the impurity, that part will become N-type. So we can make the PN junction by doping with pentavalent impurity. So here the characteristics of the PN junction. The junction means there is a junction point between two kind of materials. So the junction, we can take a line passing through exactly from the middle. If you call that as a junction, the space around the junction, nearby, very nearby, this side and this side, is called depletion region. Depletion region, where there will be no charges. So the charge movement, because of the charge movement, the depletion layer will be decreased further, that we see later. The depletion region will contain no charge elements. So see, the accumulation of charges, this is important. The PN junction has two characteristics. One is diffusion and second one is drift. Diffusion is because of the gradient, that means the concentration of holes on the P side, number of holes per unit volume, and this on the other side, number of electrons per unit volume, that is called concentration or gradient. So gradient means it may increase or decrease depending on the situation. So what happens if you consider a PN junction means, first of all, there are more number of electrons here compared to P-type, because the concentration is high here for electrons and the concentration is low. So there is a gradient. The gradient will come down as we move along this side, left side. The electrons are high, and here the hole percentage is high. Concentration of holes is high compared to N region. Holes are majority carriers here, electrons are majority carriers here, and holes are minority, here the electrons are minority. So in this case, as per the gradient, as per the concentration is decreasing from here to here, as per diffusion, what is diffusion? From high to low, the concentration of holes, the holes will move from this region P to N. Holes, as per diffusion process, holes will move from P to N, and in the same process electrons will move from N to P. Electrons from N to P. This is called diffusion. So as long as they are moving and the electrons are drifting this side, there is a positive charge accumulating on this side, positive region, because the electrons are going away and leaving a positive charge, that we call ionized donor. So whenever electron shifts to P side, there is an ionized donor, that is the positive charge, and that positive charge will slowly accumulate on this region as the electrons move to other side. and in the same case the holes will move to other side, this n side, then the hole concentration will slowly come down here and increases here, and there will be a negative charge accumulating on the p side. So that negative charge is called ionized acceptor. Acceptor is a hole, electron is a donor, if you consider in that way, ionized acceptor. So this will move, and slowly on this side there is a positive charge accumulated, and on this side there is a negative charge accumulated because of the diffusion process. So the diffusion slowly goes in this way, and whenever there is a positive charge accumulated and a negative charge accumulated, quite opposite to the potential what is going on in, at the beginning. So the potential difference, because there is a developed positive charge here this side and there is a developed negative charge this side because of diffusion process, the potential difference between these two sides makes the electrons and holes move further opposite to the diffusion process. So that is called drift. How they are drifting means, see, the electrons will again move to this side, the holes again move to this side. Previously in diffusion, holes moved to that side and electron this side. After some time, where there is an accumulation of positive charge here and negative charge here, because of the potential difference between the two materials, because of the developed injected charges on both sides, the electrons will again move to that side. That is called drift. You can see what I have written here. Electron drift is on that side and diffusion is in this side. Hole diffusion is on that side and drifting is in this side. The drifting is because of the potential difference, and the diffusion is because of the concentration difference. Concentration means because of the gradient, but the drift is because of the difference in potential. This point you need to understand very well. And next, what happens with the diffusion current and drift current? Both are moving in opposite direction. After some time, see, once the diffusion current is complete, the diffusion process has come to an end. So the positive charge accumulated here and negative charge accumulated here. So the further moving of holes, once this is a positive charge, this repels the holes coming to that side. Actually stops the holes coming to that side, and accumulated negative charge on this side stops the further electrons coming to p side. So the potential difference developed actually stops the further movement of electrons and holes. So that potential is called barrier potential. Barrier potential. So slowly diffusion current decreases and drift current increases in the process. So at a particular point of time, diffusion current and drift current will become equal. So there is an equilibrium state for the p-n junction where diffusion current and drift current will be equal. At that particular point, the current flowing this side and this side will be equal. The p-n junction is formed. So when we consider a particular point or a particular line as a junction, means the current flowing through the junction and away from the junction, into the junction and away from the junction must be same. As per Kirchhoff's junction rule also you can say that. So whenever the diffusion current and drift current both become equal, a p-n junction is formed. So this is how we will actually understand what is a p-n junction. These junctions where the materials, see here the depletion region will be very small, of the size of 1/10th of a micrometer, that much small it is, and the junction is an imaginary line. where both p and n type materials are on the both sides of the junction. So this is the process of forming a p-n junction. Mostly it is used in electronic devices like diodes and transistors. Okay, this is about p-n junction. In the next session we will take up one more interesting topic.